Okay, so let's solve 53. So the function defines x plus 4z, and the constraint is x squared plus y squared plus z squared is smaller than 2. And ask you about minimum. uh, okay, so basically this is the continuous function defined on defined on a compact set. So we definitely have its maximum. But we don't know whether this happens in a boundary or not. But okay. But suppose, but we can guarantee that f has minimum on boundary equal to 2. And the reason is that if not, then the f can take some value like x0, y0, and z0. X0 plus 40 is the minimum. But now x0 squared plus y0 squared plus z0 squared will be some r squared but smaller than 2. But then I can make x0 to I can make change that x0 become let me see become 2 over squared r 2 over r square root of x0, and y0 become the same factor, become the same scale the same factor. Then I plug in the f take on these 3 points will have x0 plus 40, x0 plus 40, 0, and times 2 to the r square root. And basically, since r squared is smaller than 2, so this is positive number. So this definitely will smaller than this minimum. So it makes a contradiction that this is not a minimum. So the only possibility is that x squared plus y squared plus z squared equals to 2. So actually, our true constraint is f equals to x plus 4z, and the constraint is x squared plus y squared plus z squared equals to 2. And so usually people use Lagrange multiplier to solve it, but I don't use. I use the Cauchy-Schwarz inequality. So I use Cauchy-Schwarz inequality. So Cauchy-Schwarz inequality tells that the two vectors in the product will smaller than their magnitude. So basically, the x squared plus y squared plus z squared times 1 squared plus 0 squared plus 4 squared will larger than x plus 4z squared. So their vector called xyz, this is a vector called 1, 0, 4. And this is the constraint, this is the constant, and this is what we want. So we have x plus 4z squared smaller than 2 times what is this? 1 plus 17. So basically we have x plus 4z. Minimum is minus square root of 43, and maximum is square root of 34. So the answer is C. That's it.